Hi grade 11s and welcome. In this lesson we will be learning about piecewise functions where we sketch different functions on the same system of axes with restricted domains. We will also be learning about arithmetic sequence and series. An arithmetic sequence is basically a linear sequence, and series basically means the sum of the linear sequence. And we will also be learning about equations, how to solve absolute value equations mixed with a linear equation by sketching and also by using algebra. So let's get into this first section, which is piecewise functions. So we have some questions here. A function g is defined by g of x, which is in three parts. As we see, the first one, the first equation is restricted from -5 to -2. It has a restricted domain. What's important to note is that this part is including and this part is excluding. So when it's including, we usually circle and we fill in the circle. When it's excluding, we just leave it as an open circle. How do we know whether if it is including or excluding? A line underneath says that is including, on the one without the line, inequality without a line underneath, which is an equal to sign, it means it's not equal to, so it's excluding. Anyways, the first the first graph is negative x minus 2. It's a linear graph which is in the form mx plus c. Remember, y1 is equal to mx plus c. So we can find x-intercept and y-intercepts. As we see, the first graph and the third graph both are linear. So in order to draw a linear graph, we can just connect 2 points. So if we substitute -5 inside this function here, we have -5 minus 2. So if we try to use the calculator, so what we have, if we substitute -5, we get 2 points. -5 will give us a 0.3. So that's the x value, that's the y value. And if we substitute -2, so -2 will give us 2. 2 minus 2 is 0, so -2 gives us 0. If we try the same method here, if we substitute 2 inside this function, we will get 2 and 0. And if we substitute 6 inside this function, we will get 6 and 4. So we have 2 coordinates, we can join straight line. Now what about the middle one, which is negative x squared plus 4? Negative x squared plus 4, which is the second graph, is written in vertex form or the turning point form, which is a into x minus p all squared plus q. We know the value of a in the front is negative, so we know that the graph is basically a sad face, it's a frown. And the vertex, we can figure out the vertex, it is 0 and positive 4. And if we substitute x value as 0, we can also find the y-intercept. The y-intercept is 4. And to find the x-intercept, we can say x-intercept is solving the equation, which is 0 equals negative x squared plus 4. So we can take the x over, we get x squared is equal to 4. So x is equal to plus minus 2. So we have two x-intercepts, we have a y-intercept and the vertex. As you can see, the vertex and the y-intercept is at the same point. So let us sketch these graphs, -5 and 3. -5 and 3, let's just zoom in a bit. So the first coordinate is -5 and 3. So we go to -5 and 3. It's right there. It should be included. Then the next coordinate is -2 and 0. -2 and 0. Remember, -2 is not included. So -2, 0. -2, 0 will be here, not including. And we will draw the straight line because it's linear. It's a linear function, so just draw a straight line. Should you use a ruler to draw these graphs? Right, that's my first graph, where we have minus 5 and 3, minus 2 and 0. The second graph is a vertex at 0, 4, and my x-intercepts were plus and minus 2. If we're looking at minus 2 is not including, but 2 is and 2 is not including, so we go to minus 2 not including, 2 not including, and go to the third point, which is the vertex 4, 0. So we need to draw a frown graph. Just neatening up here. And that's my second graph, which is the parabola. And the third graph is a straight line, 2 including, and the 6 needs to be including, which is x minus. So 2, 0 is including because there's a including here. So 2, 0 needs to be included now. So we fill in the circle, and at 6 we need a point which is 4, 6 and 4. Yes, 6 and 4. We go to 6 and 4 right here, and that should be including as well. And now we will draw the graph, a straight line. In order to draw a straight line, we just need 2 points and connect them. Right, so now I have my piecewise function, which is drawn into 3 parts, 1, 2, 3. Next question is find the domain and the range. If we want to find the domain, we look on the x-axis. What are the domains? Domain is looking on the x-axis. Domain will be from negative 5 including to minus 2. Remember, minus 2 is not including. So domain is x is an element from minus 5 including to minus 2 not including, union negative 2 to 6. Negative 2 to 6, but 6 including. You can write it in interval notation, or you can write it as negative 5. X is greater than equal to negative 5 but less than negative 2, or from negative 2, x is greater than negative 2 to less than equal to 6. It basically means the same thing. You can write it in inequality notation or in interval notation. What's the range? For the range we are looking at y values. We want to see where the graph is sketched and defined. So at 0 is the graph defined. Yes, so from 0 to 4. Is it from 0 to 4? Yes, the minimum value is 0 because there's no graph here at negative 1 or beyond 0. So from 0, for the range we look up, and for domain we look from left to right. Now from bottom down, so the range is from 0 to 4. Range is 0 to 4. So y is an element from 0 to 4. Or we can write it as or we can write this as y is greater than equal to 0 but less than equal to 4. Remember, 4 is defined, and at 0 the y value of 0, we have two different points, which is negative 2 and 2. So that's also defined, right? So from 0 to 4 is my range, and my domain is as we have worked it out here. Next one, the graph is given, the graph of the piecewise function is given. We need to find the function itself, something like in this form. We need to find the f of x function. So looking at these, we can look at 1, 2 and 3. So whenever we're trying to write out a piecewise function from the given sketch, we need to look from left to right. So from -4 to -2 we have the first graph. So we can say this is just a horizontal line from -4 to -2. So y1 will be equal to, the first graph will be equal to -4 to -2. That's a domain, both including to -2, and the function is y is equal to 2. If that's the case, you don't have to write if, you can just write a comma and write it down. The second graph is in the form mx plus c. So we can see the y-intercept is 2, and what's the slope? In order to find the slope, we can take between any 2 points. So I'm just looking at this triangle here. So I'm coming down and then to the left. So coming down 2 units down, 2 units to the left. So -2 over 2, x plus 2. So which is x, -2 divided by -2 is 1. So x plus 2 for which domain? Domain is from -2 to 3. From -2 to 3. Remember, -2 is not including and 3 is not including. And the third one, there are other ways to find the slope. You can say y2 minus y1 over x2 minus x1. So you can take 5 minus 0 divided by 3 minus -2. So we have 5 over 5, which is also equal to 1. You can take these 2 points and say y2 minus y1 over x2 minus x1. That's another way to find the slope. Now for the third graph, it's also in the form y equals mx plus c. So in order to work out the third graph, we can say mx plus b or mx plus c. M is the slope. I will use y2 minus y1, or just change in y over change in x. So if I come down here, what's the change in y and what's the change in x? So we're coming down 1, 2, 3, 4, 5, 6 units down, so -6, and we're going 2 units to the right, so positive 2 x, not x. So that should give us -3, right? That's the slope. And to find the value for c, we have to substitute one of the point that is on the graph. So we will say y is equal to -3x plus c at choosing a point that lies on the graph, which is 3 and 3, at 3 and 3. Because if we continue this line further up, you can see the y-intercept is like going somewhere around 9 or something. So if you substitute 3 and 3, y is equal to 3, x value is 3, so -3 times 3 plus c. And if we take this -9 on the other side, we get c is equal to 12. So my third graph is equal to -3x plus 12. If from 3 to 5, if the domain is from 3 to 5, x values is from 3 to 5. So in total, if I want to write down all these 3 things, we can write it as a split function f of x. So we say f of x is now equal to, the first graph was 2 if the value was from -4 to -2. The second graph was a straight line graph, which is x plus 2 from -2 to 3. And the third graph was from 3 to 5, both including, and the function was -3x plus 12. -3x plus 12 if 3 x is greater than 3 but less than or equal to 5. And this is the function, this is the answer to this sketched graphs. piecewise function. Now next one is write the function f as a piecewise defined function. So how can I write this absolute value function as a piecewise function? We have a definition for absolute value of f of x. Absolute value of f of x is equal to f of x if f of x is greater than or equal to 0, negative f of x if f of x is less than 0. Now applying this rule in here, so the absolute value of 2x minus 8 is 2x minus 8 if 2x minus 8 is greater than or equal to 0, and negative into 2x minus 8 if 2x minus 8 is less than 0. We will solve 2x minus 8 greater than or equal to 0, so we still have to write it in absolute value form, simplifying the inequality. So this will just be 2x minus 8 if x is greater than or equal to 4. How did we get 4? We take the 8 over and we divide it by 2. Remember, we have to solve this inequality, which is 2x minus 8 is greater than or equal to 0. So x is greater than or equal to 8. So x is now greater than or equal to 4. We're not dividing by negative 2, so no need to change the sign. If we had to divide by negative, then we change the sign. In this case, there's no negative, so x is greater than or equal to 4. And the second equation is negative 2x plus 8 if x is less than 4. So this is the final answer. This is simplified inequality with the absolute value functions simplified. In section 2, what we are doing is finding arithmetic sequence and series. So just a brief overview for arithmetic sequence and series. You know, when we have an arithmetic sequence, these are the important formulas that we need to know. First, what's a recursive sequence? A recursive sequence is an. Before we do recursive, we need to know what's explicit sequence, right? So explicit formula, we need to know what's the explicit formula for the terms. An is equal to a1 plus d into n minus 1, which means that a1 is the first term, d is a common difference, that's n minus 1, and an represents the term number. The same thing in recursive. In recursive form, we can write an is equal to an minus 1 plus d, where a1 is equal to something, or you can write it like this as a split function. You can write is equal to some constant if n is equal to 1, whatever the constant value is, the first a1 value, you got to write down the a1 value here, and this is just an minus 1 plus d if n is greater than 1. In other words, 2, 3, 4, 5, n is greater than 1. Instead of writing n greater than 1, you can write n is greater than equal to 2. Starting from 2 onwards, we use this second formula. And the sum of n terms, the sum formula, we gotta know. The sum formula is given by Sn, which is n into a1 plus an divided by 2. In other words, n over 2 into a1, first term, first plus last terms. It's the first term plus the last term divided by 2 times n. So let's take this n over 2 out, times n. So these are the important theory that we need to know for this section, as well as how to write a sum in sigma notation. If you want to write a sum in sigma notation, we say sigma k equals 1 to n of AK formula. What's AK formula? Instead of writing n in terms of n, we write it in terms of, so think about the AN formula, and 90% of the time it is the explicit formula that we use. What's the AN formula? The explicit formula that we need. Now solving this, given the arithmetic sequence 2 3 5 8, given the arithmetic sequence should be 1 3 5 8, not just 1 second. Is this an arithmetic sequence? 1 3 5, so we are adding 2, should be 1 3 5 7. Yes, so the arithmetic sequence is 1 3 5 7, should be 1 3 5 7. Write down the next two terms of the sequence, so 9 and 11. So we're basically counting in odd numbers, 1 3 5 7. How do we know that the sequence is arithmetic? Because we are adding the same number each time. We are adding 2, adding 2, adding 2, and so on. Write down an explicit formula for the sequence. What's the explicit formula? Explicit formula is AN is equal to A1 plus D into n minus 1. A1 is the first term, which is 1, plus common difference is 2. How do we get the common difference? We take the second term minus the first term, or the term after minus the term before. So we can see, since we said we were adding 2 each time, that is your common difference. So 2 into n minus 1. That's it. You can leave it in this form, or you can simplify. So we have 2n minus 2 plus 1, so we can get 2n minus 1 in total, or you can just leave it in this form. Next one, find the 150th term using the explicit formula. To find the term 150, we need to substitute a 150 in the place of n. So we're trying to find the 150th term, so you say 1 plus 2 into 150 minus 1. Or if you are using this, you can say double 150, which is 300 minus 1. You should get 299. Or you can use this formula and check if you're getting the same answer. So 1 plus 2 into 150 minus 1, and we are getting 299. The fourth one is should be 1 2, example 3. The fourth one is to find the sum to 30th terms. Sum to 30 terms. Sum to 30 terms will be Sn is equal to n into a1 plus an divided by 2. So we need to know what is a30, because we need to know what's the last term. A30 will be 1 plus 2 into 30 minus 1. So 1 plus 2 into 29. We should get 59. So since we know what is A30, 59, we can find the sum to 30th term. So n is 30 into, what's A1? A1 was my first term, which is 1 plus 59 and divided by 2. So we can say 30 into 60 and divided by 2. We will get 900. I hope you understand, guys. Next one. Given the explicit form of the arithmetic sequence, write down the recursive. So we want to write down the recursive from the explicit. So if we're looking at the explicit formula, what we notice here is that A1 is equal to 6 and D is equal to 3. So what's the recursive form? Recursive form is AN is equal to AN minus 1 plus D if A1 is equal to. So what's AN? AN is equal to AN minus 1. What is D? Plus 3 if A1 is equal to. You have to write what's the first term. Otherwise we will not be able to generate second, third and fourth terms. So if a1 is equal to 1, that's if a1 is equal to 6, in this case it is 6. Next question, we have the arithmetic sequence, which is we have the recursive form. Now we want to write down the explicit form. Explicit form is an is equal to a1 plus d into n minus 1. We know that this is a1 12, right, and that is the common difference, which is minus 2, so d is equal to minus 2. Now we take all this information and we put it here into the explicit form. So an is equal to a1 is 12 minus 2, d is minus 2 into n minus 1. That's your answer. You can leave your answer in this form, or you can open this equation up. You can say 12 minus 2n plus 2, which is negative 2n plus 14. So I would suggest just leave it in this form, or you can have it in simplified form. Next question, we want to find the sum. We want to find the sigma sum of this function. So we will generate what sum we need to find. So we'll generate the terms of this sequence or the series. So if I substitute k is equal to 1 inside here, so you got 2 times 1 minus 3, which is negative 1, plus move on to the next k value. This was when k was equal to 1. Now when k is equal to 2, and so on. If k is equal to 2, 4 minus 3, which is 1. If k is equal to 3, you got 6 minus 3, which is 3, plus so on, and the last value is 12. So you got 24 minus 3, which is 21 when k is 12. Now how many terms are there? There's, if you're counting from 1 to 12, there are 12 terms. So we know n is equal to 12 terms. Okay, we know that this is the a1, the first term is a1, and that's the last term, which is a12. So we want to find the sum. The sum means S12. S12 is n over 2 into n into a1 plus a12, n into a1 plus a12 divided by 2. So n is 12, a1 is minus 1 plus 21 divided by 2. So it looks like we have 6 times 20, which is 120. We can just verify this on the calculator. 12 into, on the numerator we will have 12 times 20, 12 times 20, and we will divide it by 2, which is 120. You can also check this on sigma notation. Shift sigma. Remember, we're just changing the counter, so k is equal to 1 to 12. You got to show all your workings, so you have to use the series into 2 alpha x minus 1, and if we press equals, oh sorry, it was 2x minus 3, not 2x minus 1. That's why we're getting a different answer. 2x minus 3. So we are getting 120. Instead of k, change the k. It's just a variable. It's a counter variable. So change the k into an x. We should get this answer, S12. Sum to 12 terms of this. Next one, write the sum in sigma notation. In order to write a sum in sigma notation, we need to find the, so this is basically equals to k equals 1 to n terms of AK formula. So we need to find what's the AN formula, which is A1 plus D into n minus 1. A1 is the first term, which is negative 52. D is, what are we doing every time? From minus 52 we want to minus 47, so we adding 5. From minus 47 plus 5 we're adding 5 again, so D is 5. So add 5 into n minus 1. If we simplify this, we got negative 52 plus 5n minus 5. We have 5n minus 57. So 5n minus 57. Now we need to change the n into a k. So this answer will now become k equals 1 to n of, what's AK formula? 5n minus 57. Now we have a problem because we don't know how many terms there are. So in order to solve that problem of how many terms there are, we need to equate this last term an with 23. So we'll say an is equal to 5n minus 57, which is equal to 23. So we have 5n is equal to 23 plus 57. 23 plus 57, that's going to give us 80. So therefore n is now equal to, we just take 80 and divided by 5, you should get 16. So now we know there are 16 terms. So now that n we can change to 16. So k equals 1 to 16 of 5n minus 57, and that's how we solve the problem. So this sum, the sequence of numbers which is summed up, this series can be written as a sigma notation like this. Okay, if we substitute 16 and check if the term is actually 23, you should get, if I substitute k equals 1, 5 minus 57, which is minus 52. So we did not need to find the sum of this, we just needed to write this sum, this series in sigma notation. Well, if you want to find the sum, we can find the sum because we know there are 16 terms, and since we know there are 16 terms, that's the first thing you should do. In order to find the sum, we will say is S16, which is equal to 16 into A1, which is negative 50, I think it was negative 52, plus the last term is 23 divided by 2, if you want to work out the actual sum. So we say that is 16 into negative 52 plus 23 divided by 2. You should get an answer of negative 232. Negative 232. And we just want to verify this using the sigma notation and check if we get the same answer, negative 232. So shift sigma, and we'll say that's 5 alpha x minus 57, that's 1 to 16, and the answer is equal to negative 232. So we made a mistake here. We shouldn't have n and x. You can't have, there's nothing to substitute into this, should be a k. 5k minus 57. Just make sure that this counter and that is exactly the same. Now continuing this problem, going on to the next problem, which is solving an equation using graphs. So we can think of this as f of x, right, equals g of x. So we are just finding the points of intersection of these two graphs. Well, if you solve it algebraically, you should get an answer which is 4x plus 6, which is equal to 8x minus 10. If we take the x's over, we get minus 4x is equal to minus 10 minus 6, which is minus 16. So x is equal to 4. So the solution to this problem is x is equal to 4. But how do we use graphs to solve? So we can say the first function is f, which is y is equal to 4x plus 6. So we have a y-intercept which is making x 0. 4 times 0 is 0, plus 6 is 6. And to find the x-intercept, you're making y 0. In other words, taking the 6 over, we'll get negative 6, and we have to divide it by 4. So my x-intercept here is negative 1.5. Negative 1.5. For the second graph, which is g, we have 8x minus 10, y equals. So my y-intercept is negative 10, and my x-intercept is, taking this negative 10 over, we'll get 10 divided by 8, which is equal to, what's 10 divided by 8? 10 divided by 8, which is 5 over 4, which is 1.25. That's my x-intercept. Now plotting these graphs, let's do it in different color. Let's do the F in red and this graph here we can do this in green. So the G graph will be in green and we'll do the F graph in red. So x-intercept is y-intercept is 6 and the x-intercept is negative 1.5. Negative 1.5, that's negative 2, so negative 1.5 should be somewhere that's negative 1. An estimation, negative 1.5 should be somewhere around there, halfway in between negative 1 and negative 2. So we will sketch this graph here. Let's try to get a thinner line. Right, so we have the first graph. The second graph is 8x minus 10. So minus 10 should have been around here because I'm just taking this grid. Let's just copy this grid again. I'm just going to estimate where's minus 10, so having the same block here should be minus 10 there. Minus 10 here, and my x-intercept was 1.25. 1.25. There's a graph here. Should be somewhere around here. Four x plus 6, just double checking everything. So we had 4x plus 6, which is 8x minus 10. 4x plus 6, x-intercept, y-intercept was 6, x-intercept was minus 6 divided by 4, which is negative 1.5. Over here 8x minus 10, we got negative 10 as my y-intercept, and my y-intercept is negative 10 and the x-intercept is 10 over 8, which is 1.25. Okay, so there is a problem here because this graph meets somewhere right on top and it will meet at 4 basically. So we can't really, it's impractical to draw this graph. But if we do change the function into a simpler one like 2x plus 6, and so let me just change this function into something else. So obviously the answer won't be x is equal to 4. The answer should be, we'll solve the algebra later on, so let's just change it into something that's more practical. So what I want to do is I want to change this function g of x, because we are having a problem sketching g of x. So I will change this function into, let's change this function into 2x minus 8, something easier, into change this function into 2x minus 8, not 8x minus 10. Change this function into, yes, 2x minus, let's make it 2x minus 4. Will that work out? Yes, 2x minus 4. So I'm changing this function into 2x minus 4 because that one is not working out perfect. So we have 2x minus 4. Now my y-intercept is negative 4. My x-intercept is 4 divided by 2, which is 2. So we'll use negative 4 and 2. No, let's use a negative 2x rather. So we have a downward sloping line. So if I use negative 2x, that will make more sense, because again I'm finding a solution which is like too far away, not on the grid. So negative 2x minus 4. So if I take this minus 4 over, I will get negative 4, positive 4 divided by negative 2. So if I take this minus 4 over, I will get positive 4 divided by negative 2, which will give me negative 2. So my y-intercept is negative 4 and my x-intercept is negative 2. So this is more practical, right? So we don't need all these additional lines here. So just extending this line as well. So we said my y-intercept is negative 4, which is here. Sketch the graph in green. And my x-intercept is negative 2, so right here, and we'll join these two lines. So the solution is somewhere around here. It looks like the solution is somewhere, just need to draw this graph to scale. If the graph is not drawn to scale, you won't be able to read off the solution. You have to draw the graph exact. Still not exact. Yes, it looks like the solution is at negative 1.5, but we can, solve it by algebra. So the points of intersections gives me a solution. The reason why I'm saying it is this, because this line should be exactly right. So I think it's 1.5. Let's check. So using the algebra, we can say 4x plus 6. Using algebra now, let's do it in green. 4x plus 6 is equal to negative 2x. We said this was negative 2x, negative 4. If we take this negative 2x over, we will get 6x is equal to minus 4 minus 6. So we will get 6x is equal to negative 10. So we should get x is equal to negative 10 over 6, which is equal to negative 5 over 3. Well, in this case, it's good to find the solution using algebra and then obviously using graphs. But if a graph is given, if the grid is given, they should be equally spaced square grid. So you can see this answer is just more than 1.5. Shouldn't be like in line with that. The line is somewhere around there, so which is the same thing as saying negative 1.67 approximated solution. So in this case, you can choose either method. You use the graphical method or use the algebra method. You should get like a more simplified function to solve, not like this. You should be able to read off solutions there, like easily read off solutions. Next one, we want to solve this absolute value function with this right? So we have f of x and we have g of x. We want to see when they are, at which points they are equal. So we have the first graph f, we got the vertex will be 4 and 1, and we know this graph is a V graph, positive V graph. If we try to find the x-intercept, we will not find. If we try to find the y-intercept, we make x 0, so you get 4 plus 1, which is 5. Y-intercept is 5. Vertex is at 4, 1. And if we try to find x-intercept, we can't find x-intercept because remember, we have to make this equal to 0. So absolute value of x minus 4 plus 1 is equal to 0. In other words, remember the equation was y is equal to absolute value of x minus 4 plus 1. So if you're making y 0, you will have this equation, and you can't solve this equation because absolute value of x minus 4 is equal to negative 1. Absolute value of a number can't be negative, so we say no solution for x. There's no real solution for x. So in order to sketch this graph, we need y-intercept, which is 5. 5 is somewhere in the center, 4, 5. And x-intercept is nothing. Vertex is 4, 1. 4 and 1. That's my vertex. Vertex is somewhere around here. X value 4, y value 1. That's my vertex there. 4 and 1. Now sketching this graph, obviously that's my graph here. Take a thinner line. Let's sketch this graph. We have to draw the graph to scale, otherwise we will not find solutions. Now just like how we have this vertex 4, 1, now how do we know how to slope the line for this absolute value function? So it will be nice to substitute a value like 8 inside here. 8 minus 4 is 4, 4 plus 1 is 5, so 8 gives me 5. So you just write here. I just substituted any point. You can substitute 6 if you like. So if you're going to substitute 6, you will get 6 minus 4 plus 1, which is 3. So 6 and 3 is somewhere around here. Right, so now we just join this graph. Let's take it up. Yes, and now we have the absolute value function graph drawn. Let's a little bit more down. And the next graph we're going to draw is half x plus 2. Now for half x plus 2, what's happening with half x plus 2? The slope is the y-intercept is 2, and y-intercept is 2. Let's continue this graph forever. And my x-intercept is negative 4. Now how do we get negative 4? G graph is y equals half x plus 2. So my y-intercept is 2. 2 is a y-intercept, which I've marked off here. My x-intercept is taking the 2 over, making y 0. So minus 2 divided by half. Minus 2 divided by half, you should end up with minus 4. Now sketching this graph, if we have to sketch this graph, we should get something like this. So we can see there's 2 points of intersection. One point of intersection is here, which is at 2. So the answer for x is equal to 2, or the second one is happening somewhere around here. It's like after 8, it looks like it's happening at 10. If you drop a vertical down, x is equal to 10. So these are my two solutions using graphs. Now what if was the graphical method easier here, or using algebra? Let's apply the algebra here. X minus 4 plus 1 is equal to half x plus 2. So applying algebra knowledge here, absolute value of x minus 4 plus 1 is equal to half x plus 2. So what we will do is keep the absolute value on one side and take this 1 over. You will get half x plus 1. Now in order to solve this absolute value equation, we will square both sides. So when you square the absolute value only falls out. If there was a negative, even the negative will fall out. So we got x minus 4 all squared is equal to half x plus 1 all squared. Now this is the same thing as squaring a binomial. So we have x squared minus 8x plus 16. In other words, a squared plus 2ab plus b squared. If we square this, we get quarter x squared. 2 times half is 2 times half x is 1x. So plus x, and then square the 1, you get 1. Solving all this, 1x squared minus quarter x squared is 3 quarter x squared. Minus 8x minus x is minus 9x. And 16 minus 1 is plus 15, which is equal to 0. Now we need to make this into standard form, which is ax, in other words, make this a 1 in the front. So we'll multiply every single term by 4 over 3. Multiplying by 4 over 3 gives me this equation. So you have an option of solving either by graphs or using the algebra. So multiplying this equation by 4 over 3. So 3 quarter times 4 over 3 is 1 because it's a reciprocal. So x squared minus 9 times 4 over 3, you should get minus 12x. We can check. Minus 9 times 4, negative 9 times 4 over 3. Right, so we should get negative 12. And 15 times 4 over 3, the last one is 15 times 4 over 3, we should get plus 20 is equal to 0. Now factorizing this is x, and the only numbers that work is 10 and 2. 10 times 2 is 20. Negative 10, negative 2 gives me the sum, which is negative 12. So x is equal to 2 or x is equal to 10. And that's the solution to this problem here. Just the first one, try to solve it the algebraic method. Obviously if there is a solution, you should be able to read off the solution easily, not in this case where the point is negative 1.67. It should come to like a neat point, like negative 2 or negative 1. It all depends on the functions given. I hope you understand, guys, and don't forget to comment on the video if you like it. Thank you.